Hey, so welcome to this new tutorial on Nuclear. And this time we're going to be talking about drawing primitives onto the screen. So, circles, triangles, squares, all this kind of stuff onto the screen. Possibly even animating those. Okay? So here we have the file corresponding to tutorial 1. Let's just compile the file to see what we got, just to see where we stand. Okay. So yeah, so just basically a window, very simple window. We have here a label, hello world label. We're gonna replace this label by our canvas. Okay, so by the surface we're going to draw, and we're gonna draw here. Let's make it just all white, and then draw our circles and squares onto it. Okay, this is our task, and then we will animate the circles and squares. This is the purpose of this tutorial. Okay, so bear with me to the end, and then we'll be able to draw in Nuclear. Okay, so the first thing we do is we have here the the first file, the main.c of the tutorial 1. Okay, I moved into the Nuclear 5 folder. Don't worry, this will be all in GitHub, hopefully, if I can't be bothered uploading them. So, yeah, the GUI here, nk begin, this is where the GUI logic begins, and nk end it finishes. So everything else in this between this nk begin and nk end corresponds to our GUI elements. So the first one, the top one, nk row dynamic, dynamically allocates space with 120 pixels height. So the width is actually dynamically allocated, so automatically allocated. If you guys want a particular width, you could just use static, row static, but let's go with dynamic to simplify things. Okay, so we need to remove this nk label, hello world, with text centered, because we want to replace it by our canvas. Okay, so first thing we need to do is delete this label. And now we have to declare our canvas. Our canvas, we'll just declare it. The command is this one here. So it's it's a structure, command buffer, and then this is the canvas. Okay, nk window canvas, get canvas. What does this mean? It means we're assigning the whole window of the application will be the canvas of our drawing. Okay, so it assigns that to the context, so everything passes through the context. It's a bit confusing, and even myself, I'm not so sure what this all means, nk command buffer and all that, but let's just assume it's what it seems to be. Okay, so now we need to allocate a space as well. So we need to declare the space we're going to be drawing. Okay, so this is the whole window, but we need to draw it in a specific particular space of the whole root window. Okay, have a root window. We can draw anywhere, but we want to draw just in that particular space, correspond to that widget. Okay, so to draw that, we need to declare a rectangle. Select nk rect. So this nk rect basically is just it is exactly what it seems to be. Okay, nk rectangle, nuclear rectangle. So it has a coordinate x, is a structure with x, y coordinates, which is the origin of the rectangle, and then width and height is the width and height of the rectangle, and that's it. It's a structure with 4 integers. Let's call it space. By the way, all these examples come from the nuclear.h file, from the documentation nuclear.h. So better than watching these tutorials is to read through the nuclear.h self-documented GUI library, which is really good. So let's assign this nk space rectangle. Let's just assign it to our widget. Okay, so we have what we need now to start drawing. We have a canvas and we have the space, which is the rectangle inside the application. We'll see what that is. And then let's just fill it with white so we can have a look. nk fill rect. So we have several options here. Rectangle is what we need. And then let's just fill it with light gray. It's a bit more visually appealing, I would say. It will be drawn using our canvas, which is the command buffer. It will be drawn in our space, it will be not rounded, so it will be fairly square. Not rounded edges, fairly square, and then the color would be this. We declare NK RGB, RGB. There are several options again. RGB is RGBA with the alphas and all that. We just want to pure bland RGB. So many color formats. Oh god. And then let's make it light gray. So let's make it. I know these pixels what to set it to. So no, this is 180, 160. Let's make it light gray to make it more visually appealing. Okay. And then let's compile this and see what. We need to close the brackets for the create and fill. Okay. Okay, so here we go. So we have a rectangle that's light gray, and we can start drawing on it. Quite cool. So let's draw a circle inside this square, shall we? So to draw a circle, we basically just go here, NK. We literally just pile up the commands. Important thing here in drawing Nuklear is that when you draw, the things that get declared to the bottom, they are drawn first. Okay, so if you want our circle to be visible, we have to draw it. We have to declare it here. So it has the circle has the commands where arguments has the buffer, which is our canvas. It has a rectangle, which is a space. I suppose it's the coordinates of the circle, width and height of the circle, and then the color. Okay, cool. So let's start. So circle, and then let's put a canvas. Okay, let's put canvas like this, and then let's canvas. Sorry, I was just thinking about something else. And then the space here is tricky because we don't want our circle to be the size of our square, because that would be just awkward. We want our circle to be XY coordinates of the same size of our square, but the width and height has to be much smaller than our square. So let's do that. And how we do it? There's a method here in Nuklear called nkrect. It's the same name as the structure, but it's a method that lets you create. It's like a constructor for rectangles. Okay, quite useful, quite clever. And then let's put it. The arguments are x, y, width and height. Space, so space dot x, and then space dot y. This is coordinates of our square. And then let's put width can be 40 pixels by 40 pixels. Why not? Chunky, nice chunky circle. And then there's the color. Okay, color could be okay, RGB. What do you guys suggest in terms of pixels? Comment below. I'm joking. Okay, so the color could be green. Why not? Dark green. No, it's a bit boring. Okay, blue. Blue is better. Okay, everyone likes blue. Okay, 160 blue. No, 60 blue. No, okay. 120 blue. Okay, why not? Let's see what happens now. Let's see what we get now. Let's prefer to fill out the space here. I'm very picky in terms of code formatting. Okay. And then here we get this result. Okay, so we get this. So notice the bounding circle of our the bounding box of our circle. Here xy corresponds to the origin of our rectangle, but we want to make it well. Let's first change the color to something nicer, because the light blue is too dark. So let's just put like 50 by 50, and then here let's put 180. Let's just make it a bit more pleasant to the eye. See if that will look better. Okay. Okay, it doesn't look really bad, but whatever. You get the idea. If you change here, if you add like 20 pixels, to the space x and 20 pixels to space dot y, we move the origin of our bounding box of our circle, and that's gonna be it moves our circle. Okay, so quite cool. And if we now move our we can now animate a circle. But before that, let me just tell you guys, for example, you can draw more things. You can draw NK. There are two types of objects: the fill and the stroke, like in Inkscape. Okay, fill and stroke. So here, if you have the stroke, you have all this NK stroke, like that. NK fill. You have all these objects: so circle, polygon, whatever, triangle, NK stroke. So let's just draw a stroke object. So for example, I don't know, just draw a line because it's simple. And so line takes your arguments. Hit the buffer, command buffer, which is our canvas. A float x, float y0, float x1, y1. It's a coordinates of the line. I don't know why not a rectangle. A strict rectangle, but okay. And then float thickness and color. Okay, so let's do it. So our canvas. And then instead of wanting a structure rectangle, unfortunately it was XY. Maybe it's finished. I think it should be finished to be wanting a rectangle would be more consistent. But okay. So Y, and then let's put our coordinates. So the space x, space dot yx, space y. Okay. Let's put the coordinates to start. Let's put in terms of origins. So let's just put like 10 pixels to the left, and then here let's put 100, and then here let's put the x. Let's put 10. Sorry, 10 and then 100. No, 100. Yes, dot y plus 10. We wanted to move it along I wanted to move it along the x-axis, so I'm sorry to wasting so much time. My god, just fast forward the video if this is that bad. I'm very sorry. That should be fine. Except I want 100 there, yes. So it should be fine now, okay. And then let's say the thickness could be, it's a floating number, so it could be 3.0. And then the colors, let's choose the colors. Let's put a red now for contrast with this. So let's put a red. RGB. Let's put a red. And then 2020 just to put red. Okay, so yeah. Let's have a look. The parentheses are closed. Are they closed or not? Let's have a look. Yes, they are. Okay, cool. So let's just try to see what it looks like. If I messed up the line, just to exemplify how to draw more primitives. You have the stroke, you have the line. So yeah. So it's exactly what I wanted, but okay. Okay, so yeah, that's exactly what I wanted. I need the y to be minus here 100 as well. Okay, so y 100, y is constant. Yes, sorry for that. So now what we're gonna do is we're gonna animate the drawing is quite long. So let's animate the circle. Let's move the circle to move. Okay, let's make the circle to move. So we can do that actually quite cutely by making it look like it's moving on the line. So yeah, that's our point here. So 40 pixels wide minus 100, so it would be 60 pixels. Let's see if our circle looks like it's on top, sitting on top of the line. And then if it does, then just make it move back and forth. Yeah, so it does. Okay, cool. So let's just make it look like it's moving. on top of the line. Okay, so let's make the line a bit longer, 50, just to make it more space. Okay, and then here our canvas rectangle. What we do is we declare a variable called motion. Example, um, and that's gonna be in our main. So static motion, and then motion. Let's make it move along the x-axis. So motion x. And then let's call it let's show it takes the value of 0, and then every time here the motion this function nk begin anything window is called, instead of 20 for the x-axis, we're gonna add here plus motion dot x. Okay, and then we have to divide this by 150 is the length of 140. Let's do 120. 130. That's the length of the line, roughly. And that's it. That's and then we have to increment the variable motion as soon as it's done. So motion gets incremented. Motion x gets incremented. So yeah, incremented. Okay. So let's see what it does. Type defaults. Oh, okay, so warning, but it's working. Okay, cool. It seems like it's a bit out, so it's warning here. Okay, static int. We need to type in static int. It's an integer. Yes. And then here is we could get away with the char really, but I think everything in Nuklear equals to integers. So yeah. And then let's just put 100 here. 100. Just so it doesn't go out of the line. That's annoying. Let's just see what it looks like, our animation. Our great animation, okay? So it looks like this. Okay, so it's not so bad. It's going back to front of the line without going backwards. Okay, it's just not so smooth. I'm sorry for not being so smooth, but you get the idea of how to animate objects in Nuklear, and the story is quite long now, so very sorry for that. But see you guys next one. See you.